Welcome to this explainer, where we're diving into how a startup called Diode is actively bringing the lightning-fast iteration of software development straight into the physical world. Look, if you're a hardware founder or an investor, you already know the painful truth. Building physical electronics right now is fundamentally broken compared to just spinning up a SaaS app. So today we're going to unpack exactly how Diode is creating an automated infrastructure layer to accelerate domestic hardware manufacturing, and how they're basically rewriting the rules of physical product development. To really set the stage, let's look at this incredibly fascinating vision straight from Diode's CEO, David Aznagi. It perfectly captures the exact headache founders are wrestling with. Before the cloud, software startups had to literally buy and rack their own physical servers just to see if a product idea even worked. It was agonizingly slow and super capital intensive. Well, today, hardware startups are stuck in that exact same dark age, forced to build their own internal manufacturing supply chains totally from scratch. David's thesis is simple but powerful. We desperately need an AWS for electronics to finally democratize hardware. So here is our roadmap for today's explainer, designed to unpack this massive startup opportunity step by step. We'll hit 1. The circuit board bottleneck. 2. Artisan craft versus scalable automation. 3. Building an AWS for electronics. 4. Automating design with large models. And finally, 5. The upcoming hardware renaissance.
All right, let's jump right into part 1, the circuit board bottleneck, which is basically the neglected middle child of electronics.
To understand why printed circuit boards are stuck in the past, you really have to look at the two extremes of tech development. On one hand, you have silicon design, designing actual microchips. Because getting a silicon chip wrong costs millions of dollars and causes absolutely catastrophic delays, the industry has poured billions into highly optimized tools to guarantee first-time success. But then, on the completely opposite end of the spectrum, you have software development. If you write a bad line of code, the failure cost is practically zero. You just push a patch, right? It allows for instant, totally fearless iteration.
But printed circuit boards, those essential copper and fiberglass planes connecting the chips in our phones, drones, and robots, they fall awkwardly right in the middle. Just think about this. $10,000 to $80,000. That's what a single incorrect spin or prototype of a PCB costs a startup founder. It's enough to seriously slow down your growth and burn precious runway. But it's not quite company-destroying like silicon. And because it sits in this weird, forgiving but expensive middle ground, the tools and infrastructure for PCBs here in the US have just been completely neglected.
Which brings us to part 2, artisan craft versus scalable automation, and why the old way of doing things is totally breaking down. There is a stark contrast between the old artisanal way of doing things and Diode's bet on automated, high-yield digital infrastructure. Currently, a lot of domestic US shops are set up perfectly for mass volume of a single finalized design. But the second a startup needs rapid, high-variance prototypes, the whole system breaks down. Designers are manually tweaking boards, often completely ignoring the downstream assembly line yield. If you place a component just a fraction of a millimeter off spec from what the manufacturing robot expects, the entire line fails. Diode's scalable digital approach forces a co-design. The board is designed from the very first click with the strict parameters of the automated factory line in mind. And this leads to a massive problem. Founders are basically trapped in this hardware edition of the tragedy of the commons. Imagine a brilliant robotics startup in San Francisco. They have incredible software and AI talent. But instead of focusing on that, they're forced to burn through their venture capital acting as supply chain logistics experts, trying to source copper and wrangle manufacturers. Everyone is just redundantly reinventing the exact same manufacturing wheel. So what's the solution? Let's move to part 3, building AWS for electronics. The disruptive digital layer. By acting as a digital copper merchant, Diode is providing a service where startups actually own the output, the brilliant IP, and the physical circuit boards themselves, but they don't have to own or manage any of the expensive complex factory machinery. They're building a massive facility in Brooklyn that acts effectively as an API for physical copper. You just send them your specs, and they seamlessly handle all the messy real-world physics of getting that board yielded, assembled, and shipped right to your desk. To achieve that kind of massive scale, we have to talk about part 4, automating design with large models, or what you might call the LLM-powered engineer. Get this, by partnering with Anthropic's Claude, Diode has already automated 90% of schematic drafting. 90%. Schematics are basically the logical graphs of the board, right? And because they actually function a lot like software code, the LLMs are incredibly adept at just one-shotting them. The model does all the heavy lifting, connecting the logical dots, and then a highly skilled human engineer steps in for that final 10% just to polish, review, and ensure absolute reliability. Now, physical layout and routing are a much harder visual task. Visual reasoning in a 3D physical space with real-world physics is notoriously difficult for AI, but even so, the models are already tackling 40 to 50% of this workload. Diode's models are actively learning to match component placement exactly to the precise specifications of the manufacturing machines. This ensures that when the board is physically printed, the robots aren't going to make a single mistake putting it together.
For a founder using this platform, the journey is incredibly streamlined, and it beautifully aligns with how software engineers are already used to working. Step 1 is just capturing your exact specs. What do you need this board to actually do? In Step 2, Diode's LLM agents instantly get to work drafting those schematics. Step 3 brings in their internal human engineers to review the model's output in what they call a trust but verify stance. And finally, Step 4, it's manufactured on their automated line and shipped straight to you.
Let's talk about the massive efficiency advantage happening on the back end here. Every major electronics company usually has a dedicated human librarian whose entire job is just reading incredibly dense PDF data sheets to catalog symbols and footprints. It is tedious, highly error-prone work. Well, Diode turned their AI into a super-powered librarian. It manages these complex symbols, reads the dense data sheets, and automatically prioritizes historically validated parts. It even generates human-readable code outputs. By stripping hours of manual, repetitive work from design timelines, human electrical engineers are finally freed up to focus entirely on high-level system architecture.
Okay, let's tie it all together in part 5, the upcoming hardware renaissance and what this actually means for startups and investors out there. For their aerospace and robotics clients, this technology is actively collapsing development timelines from 9 agonizing months down to an astonishing single month. Just think about the competitive advantage there. If your competitor takes almost a year to validate a single physical prototype, and you can spin up 9 different variations in that exact same time frame, you win the market, period.
For venture capital and ambitious founders, this is the wedge that finally democratizes physical tech creation without bleeding cash on giant engineering teams. Right now, a Series B or C hardware startup might literally need to hire 100 electrical engineers just to handle the sheer volume of board revisions they need. But with an API-driven infrastructure, that same startup can scale incredibly fast, highly efficiently, and with a fraction of the headcount. It essentially makes hardware startups look a lot more like high-margin SaaS companies. And on a macro level, it actively accelerates the reindustrialization of the US by pairing world-class software talent with totally accessible manufacturing. So I'll leave you with this final provocative thought to take away from our explainer today. The friction of the physical world has held back thousands of brilliant founders from ever actually building out their hardware ideas. But if Diode succeeds and that friction effectively goes to zero, what hardware will you build next? Thanks for joining me to unpack this fascinating source material. I'll see you in the next one.